Hello Year 9, so we're just going to do a quick recap for today's lesson of stuff that you would have done previously on how to convert denary to binary and binary to denary. So here we have our binary number, and don't forget one of the things we need to do is to put on top our values, so we double each time, and then what we do is we begin to add these numbers up. So anything with a 1 underneath it, we add up. So it's 128 plus 16 plus 8 plus 2 plus 1. So if we add these two together, we get, so that becomes 144. Then we add the 8, becomes 152. Add the 2 is 154. Add the 1 is 155. So our answer here, this binary value here, equates to the denary of 155, the decimal number 155. If we're going the opposite way, so let's see if we were correct, we'll do 155 and we want to convert that into binary. We can say, does a 128 fit into 155? If the answer is yes, we put a 1. If the answer is no, we put a 0. In this case we put a 1. We then do 155 minus 128. So we borrow 1 and we have, what's that, 7 left. Take that 2. So we say on 27, does 64 fit into 27? That's a no. Does 32 fit into 27? No. Does 16? Yes, so it's a 1, and then we minus off the 16. So 7 minus 16 is 1. So we say, does 8 fit into 11? Yes, so we put a 1. We minus the 8. The answer is 3. Does 4 fit into 3? No, so it's a 0. Does 2? Yes, because it's a 1. And we minus the 2, that leaves us with 1. 1 fits into 1, so we put a 1 underneath it. So this number here then is 155 in binary, and that should be the same number that we have above. So we've checked our answer, but that's how we go from binary into decimal. So we've converted this number here into this number here, or we've gone the opposite way by converting this number into the binary number here. So one of the things that we can do now is move into something called hexadecimal. So if we were just to look at the language that we've got, hex, you may have heard the word hexagon, which has 6 sides. So hex means 6. Decimal, well, the des bit means 10. So we put them together, we've got 16. So hexadecimal here, we're going to use what's called base 16. Now that means there's 16 different values that we can have, and those different values go from 0 all the way up to 9. Then when we reach double digits, so we reach 10, that becomes A, and we go all the way to F. And you'll see here, if we count these up, there's 16 different values altogether. So 0 to 9 gives us 10 different values, and A to F gives us 6 different values. So this is what we mean by base 16. There's 16 different values that can be represented. So each one of these values is represented by a nibble, which is 4 bits. So let's say, for argument's sake, we take the number that we've got here, this binary value, it may have been in times when computers first came out that you would need to remember this. So one of the things that came out was hexadecimal to try and make it easier for humans to remember. That's it. The only reason we use hexadecimal is to make it easier for humans to remember, therefore they'll make less mistakes. So what we do is we split each of these up into 4 bits. So we count 1, 2, 3, 4 and we draw a line. 1, 2, 3, 4, draw a line. 1, 2, 3, 4, draw a line. 1, 2, 3, 4. And we keep doing this until they've all been separated out into 4 little bits. So here we've got 1, 2, 3, 4, 5, 6, 7 nibbles. Now, if I ask you to remember that whole binary number, you may make a mistake. You may get them wrong because it's just, 0, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1, etc. But if I was to say to you, well, okay, actually, the numbers that I want you to remember are 6, E, B, D, 9, 7, 7, you might find that easy to remember. 6EB, D977 is a lot easier to remember than all these 1s or 0s. So how do we convert hexadecimal? How does it work? Well, let's take a binary number and we'll start off with 4 zeros. So that, not hex, sorry. So that's the binary. We then got our decimal number and our hex. And in decimal that's 0, and in hex that's also 0. If we took the next one then, it would be a 1. In decimal, that represents the number 1. Therefore in hexadecimal, that represents the number 1. We now have 2, and you can see they're following a similar pattern with the binary and hex. And what I'm going to do is say this goes all the way up until you get to 9. What happens now when we get to 10 in binary? So 10 is 10 in decimal. In binary we've got 1010. So hexadecimal, this becomes A. We then take the next one, which becomes 11. That becomes B. 12 is C. 13 therefore is D. 14 is E. And 15 is F. So one of the things that we need to be able to do is to convert a binary number into hexadecimal, or hexadecimal into binary, and then into denary. So the first thing that we'll go through, because it's a bit easier, is we'll do hex to binary. So hexadecimal numbers always come in double digits. So let's take the hexadecimal number. We'll go with A6. So to convert this, we take our number and we split it up. So we've got A6. A we know is 10. Therefore we will write that out. 6 we write in binary. So when we put these two numbers together, that makes our whole binary number. So this binary number here is being converted from hexadecimal into binary. That's it. we split the number in half, like we have done here, and then change each one into its respective nibbles. So when we go the opposite way, if I was to do the tell you what, let's do another example. So I might have, for example, 9 1. Let's do that. So let's say we've got 91 and we're told this is in hexadecimal. So it looks like 91 to us, but in actual fact it's two different values. It's 9 and 1. So 9 we write out, and 1 we write out. When we bring these together, that's our binary number. So let's do binary to hex. Well, it's a similar process to what we've just done before, but we reverse what we do. Let me take this number here. Again, we count the 4, 1, 2, 3, 4. We put our line. We separate these out. Each one of these then, we go 1, 2, 4, 8. 1, 2, 4, 8. Notice because they have been separated, it's two different nibbles. So we start each one. We'll only have the numbers 1, 2, 4, 8 above each one. We then add them up. So that is 14, and that one is 13. Now we know we can't have 13 and 14 in hexadecimal, therefore that one must be E and that one is D. So this number here in hexadecimal is ED. So the binary number we've been given here is ED in hexadecimal. So that's converting binary to hex. What I'd like you to do now is to have a look at the Bag of Cows website, and there are some questions on there, hexadecimal and binary, and if you give them a tick, that means that you can then do some questions on there, see how you're getting them. Ideally, you're going to be aiming to getting them right, so keep working until you've got 10 correct answers. It's more about you getting the answers right now rather than about you getting them done in a certain time frame, etc. You just got to keep practicing until you get the correct answer. Use the videos on the course website to help you as well if need be, or you can pause and rewind this video to help you as well. So what we're going to move on to now is hexadecimal to denary. So there are two ways of doing this. I'm going to show you both ways and you can pick whichever way works for you. If we continue on the example that we've just had, so tell you what, let's do hexadecimal to denary. Well, if we've got the value, let's go with 2, 4. So for us it looks like 24, but in hexadecimal it's 2, 4 because they are two different values. What actually happens is the value in the right side is 16 to the power of 0, and on the left side it's 16 to the power of 1. So what this means is that whatever number is here, we times that number by 16, and then we add it to whatever number is here. So this this hexadecimal number can be rewritten as 2 times 16 plus 4. And 2 times 16 is 32, plus 4 is 36. So our answer now would be 36. So that's one way of converting hexadecimal to denary, is by using your times table. So if you your 16 times tables are going to come in very handy, and we will be practicing them, we will be learning them as we go. So one of the things that we've got is an easy way of converting it by using our 16 times tables. The other way is we can do what we did before. So we've got 24. So let's split this up again. 2 then is like this. 4 looks like this. And then when we put this together as one whole binary number, we get 0, 0, 1, 0, 0, 1, 0, 0. If we then do our normal conversions that you are used to, we can see the numbers we want to add up are 32 and 4, which gives us 36. So whichever way you want to do it, the first way is by using the 16 times tables. The second way is by converting to binary first and then adding the binary values up. It's whichever way works best for you as an individual. My personal recommendation would be to try and get this one done, because we're pulling in the same skills that we do in maths, where we're using our times tables, we're using our BIDMAS, and you tend to be a lot more accurate because there's a smaller process in terms of what is going on. So that's one way of converting hexadecimal into denary. The final bit now, what we'll have a look at, is converting from denary to hexadecimal. So let's say we have the number, let's go with 167. So one thing that we can do here is we can divide. So when we convert in the other way, we times. Well, the opposite of times is to divide. So what we can do is we can divide this number by 16. So we do 167. We're going to use our bus stop method, the same as what you're used to in maths. And we say how many 16s go into 1, and that would be 0. We then carry the 1. How many go into 16? That will be 1, and there's nothing left over. So we say how many 16s go into 7? There's none, and then our remainder is 7. Now what's really nice about this method is this number goes on the left and this number goes on the right. So the number then becomes 10, 7. We know we don't have 10 in hexadecimal. 10 is A, so our answer is A7. Let's just show you another example of how that might work. So let's go with 241. So again, we're going to use our bus stop method. We say how many 16s go into 2? None. How many go into 24? 1. So 24 minus 16 then we can't do, so we'll carry 1. So that becomes 8. 0, so we're going to carry the 8 over. So how many 16s go into 81? Well, 10 times 16 is 160. Therefore, 5 times 16 is half of that. So that's going to be 80. So we know that's going to be a 5 with a remainder 1. So again, this number is on the left, this number is on the right. So our answer becomes 15, 1. 15 we can't do, 15's an F. So F, the answer is 1, so the answer becomes F1. So our bus stop method is going to be really, really useful, really quick in terms of being able to convert that binary number back and forth. I said I was going to show you 2 ways of doing it. So let's have a look at the other way, and we'll use the same example. So 167, and so what we do is we take the number 167, we convert this into binary, so we do the 128. Does it fit in? Yes, so it becomes a 0. So 167 minus 128. We can't do that, so we borrow 1. So 17 minus 8 is 9. Uh, 5 minus 2 is 3. And then we've got 1 minus 1 is 0. So 64 doesn't fit into 39, so we put a 0. 32 does fit in, so we put a 1 and we minus 32. That leaves us with 7. We know 16 doesn't fit into 7. We've then got 8, 4, 2 and 1. 8 doesn't fit into 7, so we put a 0. 4 does, so we put a 1. Minus 4 is 3. 2 fits into that, so we put a 1. Minus 2 is 1. 1 fits into that. And you'll see that this number here is 167 in binary. To convert that into hexadecimal, then we split the number in half and we rewrite them as nibbles. Oh, got that wrong there, sorry. So 1, 2, 4 and 8. 1, 2, 4 and 8. And as nibbles, this number is 10, this number is 7. Remember, 10 we can't have, so the answer is A7. And we see we had A7 as our answer above. So whether you're doing the going through binary method or the bus stop method, again, my recommendation here would be to use this bus stop method. I think it's easier, and I think students typically don't make as many mistakes in doing it, and do become quicker in doing that as well. So that's hexadecimal. Hexadecimal again is used purely for humans to make it easier for them to be able to remember long binary numbers. The expectation for you is to be able to convert to and from hexadecimal and denary, and hexadecimal and binary. I hope that's been useful. The rest of the tasks are going to be explained on Show My Homework for you. If you have any questions though, you can always use the course website to relook at information. Alternatively, you can talk to each other, or you can email me as well, and I will try and get back to you as soon as I can. I will be doing the session live, so hopefully you've tuned into that for anyone who has any questions. But good luck. I look forward to seeing your work.